Hello students, welcome back to Corba. See, in the previous session we have discussed all the overview part and what are the services it can provide and all. Now we are moving to the communication models. See, this is a continuity to the previous session. So just have a look of the previous session once. Now, communication models. Coming to the communication models, these models are very important because how the objects are interconnected with each other, how they are knowing that at what point which object to be enabled or invoked. So all this kind of informations are taken care in the communication models in the Corba. Now, if you have seen here, we have mentioned three types of communication types. So where synchronous is nothing more but we will be communicating with the sender and receiver. If sender is providing some input, server will be responding to that. So all this communication with which are interconnected with each other is called as a synchronous type of communication, where the failure chance is a lot when the caller blocks at one point. Now, one way is nothing but we are just providing our data. The receiver side they are taking the data or else if they have received data properly or not, all those acknowledgements we will be not having properly. So thus the failure types are unreliable and we will be never know the blocked data. So there obviously there will be no unblocking, of course. So coming to deferred synchronous, see here at least once we will be getting, at most once we will be getting the failure chances, and here the results, there is a chance of getting the results later also. So if we have stuck at one point, at last the receiver will be getting the data. That chance is there, of course, right? So this is the first object invocation type of the communication. Next, event communication. So event communication is nothing but how the objects are communicating with each other as a process of the provider and the receiver. So that is what is a producer and consumer concept. So where the supplier is always ready to provide the data, through the event channel the consumer is always ready to take the data, right? So in this case the suppliers are always pushing the data. We don't know that who is taking the data at one point. So that is what is a failure chance will be there. Now next one is when consumer asks a particular data, then the supplier is providing that data. So here ask suppliers for new events. Say always consumer will be taking the initiation to get data from the suppliers. In the above, suppliers are, the consumers are not asking for any data, but suppliers are keep on pushing the events to the consumers, right? Next one is message facilities. In the message facilities, we have to check about the reliable asynchronous kind of data, because synchronous will be always reliable, as we all know. Coming to the asynchronous reliable thing, how the data is about to store in a persistent, means this data to be, whatever the methods we are invoking at that point, how to store those invoked methods at one point. So all this will be taken care in the messaging facilities. Here, if we have one client raised with one request, then immediately its ORB will be highlighted, the activated. From here, the server will be getting the data, the request data. While server provides the responses, in the process, it will be calling all the related interfaces which are required for that particular request asked by the client. So this is one procedure. Second one, when it is asking for the responses, when it is taking the process of giving the responses, it will be asking, all the invocations through the polling interface. Right. So which interface will be available? This is a callback interface, this is a polling interface, right? Next is a process. Say process, as you all know, this is a how the Corba is related with the process, the execution procedures, how one process to other process communications will be taking place. See here, interceptor is one of the major concepts which we have to discuss here. So interceptor is nothing but it is a user return object. So where it is overlapping or it is stopping the existing flow of the execution and it is highlighting with the user return object request, right? So this object request may be having some functionality which a user need at that moment. So that may be a kind of adding a security extra. See, this is a functionality to be inserted into Corba. So this is not the existing which is already there in the service of Corba. When an interceptor arises means there is a new added insertion to be taken place in the Corba at that moment. Okay, so that may be adding few security or else monitoring few components. So whatever it may be. So this is a kind of interceptor. Now next one is a, if you can see, this is the interceptor types. We have request level interceptor and message level. So when we have request level interceptor, we have to invoke a method. Okay, when we have a message level, how the message is passing between, see, control of the messages will be taken care. Now coming to the naming. See, in the naming, why we need naming first of all? See, naming is very, very important, not only in Corba, in every system whatever we have utilizing nowadays, right? So naming is very, very important to implement objects. To call object, we should know the naming convention of that particular object. Yes, so as we all having n number of remote method invocations, so n number of objects are playing at that moment, right? So which object to be highlighted with the naming convention, right? So this may be again in two types, specification level and the implementation level. In the specification level, we are considering only referenced object. Which object I am highlighting? That object only. I mean, proxy for the referenced object only I am highlighting specifically, right? Coming to the implementation level, here whatever the object client will be utilizing, all the objects will be highlighted with the placed, I mean the highlighted with the references we call. Okay, so and all this will be implementation level. All the client requested will be saved in the client's address space. All the method namings will be saved in the client's address space. So this is what is a space where we are saving all the naming conventions of that particular level. Next is these are the two types. Now dependent is nothing but it is dependent on the implementation. So different levels of implementations will be having different levels of their executions and references, right? Naming service. See, naming service is provided by the Corba. As we all know, objects are naming, but who is providing the service? The service is provided by the Corba. So the Corba will be associated with the servers first of all. Okay, so all the servers objects of that particular names will be available at one point, right? Next, in this observation, all the names will be easier to relocate the objects also. Like when we are calling a particular object to be relocated from one system to the other system, this naming service will be provided by the Corba over there, right? And this important point is nothing but all the naming operations will be taken care by interoperable naming service, right? Now, what is interoperable object reference? See, interoperable object reference is nothing but, as we all just discussed about a road transportation, right? So in the road transportation which is provided to n number of vehicles over there, how the vehicles are utilizing that road transportation is with respect to the interoperable object reference. So what is that indicating is nothing but, see, a road is having a bicycle and a car, so which is suitable, I mean that road is giving chance to both vehicles on an equal way, right? So this is interoperable object reference, we call that as giving chance to all the components or the systems or else the objects which are executing at that moment to be in a free flow execute manner, right? So here you will be having the flow here. If you can see the flow here, there will be a bridge type, right? So this bridge, so if we have gone with C language, so enter into this bridge and become as a common platform. Next CPP, common platform. Java, enter into bridge, common platform. So from after this interoperable will be acting as a bridge over there to provide a chance to make all the objects as an equal manner, right? So this is all about the object reference, and coming to the object reference, you see once we entered into that bridge, that will be maintained in a common format, right? So which format we are having here? See, we are going to maintain a particular header format to that particular object. See, we will be having the repository identifier, profile ID of that particular tagged profile, and the what is the reference, who is providing this reference, what is the identity of that IOR, interoperable object reference, again we need over there. Next, host, port name, object key and all. So this is having a simpler header format. When we entered onto that bridge, we'll be having that format. When enter, Java will be having one format. So everything will be called in a proper way. Now coming to fault tolerance, in the Corba how we are maintaining with the fault tolerance. So the final symbol, the solution which we are going to take care is a interoperable object group reference. So this object group reference will be activating the objects into a neutralized format. So when we say normal objects, neutralized objects, so all the objects also will be transparent to the clients. So no client will be knowing that all this is happening background. All the clients can see their objects as they are calling, so as in their assumption, right? So but internally n number of things will be taken care. And coming to fault tolerance, here we will be anyhow maintaining one replica over there. If you have any failures, immediately we will mask them with the replications whatever we have. So that replications and the masking will be taken care by the object groups. Now these object groups will be called as interoperable object group reference, IOGR. Now this is having this format, right? So we'll take a backup from this. See, anyhow we are maintaining one header format just before. Along with that, to highlight this fault tolerance, we are maintaining group specification information. So which group has to be taken care immediately to mask the failures. Along with that, we will be tying up with a backup. Okay, so at that moment, if any fault occurs, immediately we'll take the backup from there, right? So all this will be taken care by the IOGRs, interoperable object group references. Finally, the security provided by in the Corba environment will be taken care by policies. Always will be having policies, right? So, and users will be always unaware that all these policies are attached internally all, but every object will be taken with the security service. When we have security services, obviously we'll be maintaining the policies at that particular client ORBs. Similarly at the server ORBs also. So every client and server architecture in the Corba will be maintained with the security policies. Thus we will be maintaining the protection with a trusted parties also. See, when we are having different kinds of parties, trusted parties are very, very important as a third parties, right? So by this we have completed Corba. If you have any doubts, please be free to contact anytime in the college. Thank you.